Good morning, all.
Good
Good
morning,
morning,
sir.
sir.
Well done. I want to quickly conclude what we started on Monday. That is X-ray production, and also going to the next topic of the day, which is screen film radiography. So I want to quickly see how much we'll be able to achieve today, because by next week and Wednesday, a new topic should be underway. So X-ray production, concluding session. We have looked at the way X-rays are produced. That is from the contribution of the differential lung portion, which is of course the major um, contributor we have. Then characteristic X-ray emission, which is much more useful in mammography. When we get to mammography, we understand why we need to increase the portion of the characteristic X-ray. We've also seen some salient points in X-ray production. We've seen Hill effect, um, which is as a consequence of the line focus and principle. And we also saw how we can use Hill effect to our advantage. That is making sure the patient we are imaging is at the cathode side of the X-ray tube, because that is where intensity of the radiation is more, because of course of Hill effect. Um, we also need to look at this off focus principle, off focus radiation. Because we want to have a perfect system, but of course, we will never have a perfect system. Off focus radiation is as a result of some of the electrons striking areas not defined by the focus spot. For example, you have this to be a focus spot, this to be a focus spot. Okay. Let's say we have this area to be a focus spot, and you have electrons coming and striking this area beyond the focal spot. It's going to give rise to X-ray beams that will be scattered in, of course, they'll be scattered somewhere around in this area. So these are X-rays that produce and constitute the off-focus radiation, and then they are not so good for the purposes of radiography. So it has to be reduced as much as possible. And when that, of course, it usually happens, it must happen. So we just place a kind of a lead attenuator close to the window to take care of all these stray, otherwise radiation. So our focus radiation is something we don't want, but we will always have them. So the best we could do is just make sure we reduce it as much as possible and focus on the major X-rays. Sorry, focus on the major X-rays we need for radiographic application. So we have okay. So we continue with other components of. I will just quickly do a recap and then go over to screen film. Want to look at the X-ray tube insert. The two inserts, like we said last time, consist of the cathode, the X-ray tube itself, um, the which of course comprises both the cathode and the anode, cathode, and then anode comprises the window. Talking about the tube insert. cathode and the anode consists of the window, the output window, and the output window consists of the what do we have again? The glass envelope, the glass or metal envelope. I think we did this last week. And of course the vacuum, the vacuum, and we have this is our vacuum. Let's take this in to be a negative electrode and a positive electrode, a cathode and an anode. We this place the vacuum, this glass envelope or metal envelope has to be evacuated so that we essentially have a vacuum. And like we said before, it is essential because as the electrons are moving towards the cathode, the anode, they shouldn't come in contact with whatever gas inside, maybe air molecules or whatever. Because if that happens, the energy of the electrons will continually be reduced because of the interaction they have with the particles here. So we want to make sure as much as possible we don't have any anything inside. We essentially have vacuum as much as possible. Of course, we can't get a perfect vacuum. And at times when we have into tube failure, or when the tube is not, it's at times because of not just because of the problem associated with the cathode and the anode. At times you can have maybe the cathode, of course, having an issue. And most times, most times the cathode having an issue. We also have that this begins to leak. When it begins to leak, it means air will be getting inside. And when that happens, that's the end of the tube. It has to be replaced. So we want to make sure the tube has well it has an almost a perfect vacuum. Then the lead shielding inside the tube inside. We have the tube inside, the whole of it, of course, we have the covering. It is embedded. It is shielded with lead, everything because when the electrons strike the anode, the X-rays are produced isotropically in all directions. So it is not just the window where you want to get the X-rays from. X-rays are produced every other place. So you have the leaded walls everywhere. All the components of the cathode, the X-ray tube are leaded, everything. We just leave a small portion which contains our collimators that define the X-ray field. So the next one is our X-ray field. And again, when it comes to this shielding here, at times when we are doing our quality control or quality assessment, we need to calculate the leakage radiation from the tube, from this tube. Because in as much as we have the lead shielding, at times the lead shielding might not be properly, that shouldn't be the word. At times the lead shielding might not be adequate, but I wonder why. That shouldn't happen anyway. It shouldn't happen. But in case we want to be sure that the facilities tube is in good condition, as specified, has a good specification, we need to measure the tube leakage, and the leakage shouldn't be more than around 100 millirankin per hour. So this is the allowed leakage radiation that we can have in an X-ray tube. It shouldn't be more than that. When it goes higher than that, then it calls for maybe additional shielding of the tube. Collimators. Then we look at the filtering. It is very, very important, very important to have filters in the X-ray tube so that the low energetic photons, low energetic, of course, and X-ray photons, which are not useful in for image and creation, image and formation, are removed. So we need to add filters. Filters can come in and you can group them in two broad categories: the inherent filters, and the added filters. The inherent ones are the ones there just because of the composition of the X-ray tube, while the added ones are those ones that have been specially added or intentionally added to take away the low energetic photon. The inherent filters, you have so many of them. The oil, the cooling oil inside the tube is part of the inherent filter because it's going to cause some attenuation of the X-ray beams coming out. We also have the window, the beryllium window, depending on the type of radiography we are doing. If it is a mammography, typically use a plastic window just to make sure we don't remove so much of the low energetic X-ray because they are needed in more in a mammography. So the window provides a kind of attenuation. So it's also a filter inherent. The mirror. There's always a mirror inside the X-ray tube. The mirror is that which defines the X-ray tube. Sometimes, most times, maybe quarterly or so, 3 times or 4 times in a year, we need to calculate the deviation between the light field and the X-ray field. So the mirror is used to project the light down the shutter, down the window. So when you put on of course, you haven't started exposing, you just turn on the knob on the collimator head. And you see light will now show on the table. If it is a table this you want to use, light will show on the table. The light is as a result of the mirror that's have a mirror inside the tube.
Good morning, sir.
Good morning.
Yes, sir, please, we can't see very well with the grain marker.
Okay. Is the red okay?
Yes, sir. Thank you, sir.
Okay, thank you. Let's see. Okay, with green and then these are the 3 colors. Color combination. Okay, we have I had already explained this before. The filters, the inherent and the added. I was talking about the mirror inside the X-ray tube. As part of the inherent filter. Why should we have a mirror there? We have a mirror there because you have a light source. Okay, this is a cathode, this is an anode. You have a cathode here. Let me just take it. A window is here, which has the collimator. it has a collimator. So we have, we should have a light source here. We have only have a light source here. A light source. So the light source has, you now have a mirror close by here. A mirror here. So when you turn on the system, even before the system starts operating, the light is going to be, of course, transmitted as topically in that direction. So we come here and be reflected down here. So the one that we pass through this window will now tell us how the X-ray is also going to come out. How the X-ray is also going to come out. So this window here also constitutes a type of inherent filtration. It's going to attenuate the X-ray beam coming out of the X-ray tube to an extent. So it's also a filter, but the mirror is made as thin as possible. Now, at the end of the day, we now have the added filter. The added filter is, of course, the ones that have been added consciously. That is deliberately added to remove the low-energetic photon. So they are all these filters inherent and added. They now constitutes the beam to have a higher effective energy. And as such, when a new machine is bought, in fact, from time to time, mostly yearly, we normally do the heavy of it, which is as a result of making sure that we have the appropriate amount of filter inside the machine. There is a table for that. For example, if you are exposing at a particular, maybe at a 70 kVp, you have a particular amount of filtering, amount of HBF value, maybe 22 millimeter, I mean, a 20 millimeter of aluminium, usually given in millimeters of aluminium or copper. So we have those, so these are just the little we need to know about filtration. Then, another component of the X-ray tube is the generator. This is probably a very, very important aspect. Generator. Okay, when you go into an X-ray room, you always see the generator maybe at the side of the room, maybe at one of the four corners of the room, dedicated, or at times it might be housed not in the X-ray room, maybe somewhere else. The generator is that which supplies power to the X-ray tube. Of course, without the generator, of course, you know what, just from the generator, we all know what a generator. It is that piece of equipment and that gives power to the X-ray tube. We don't want to go into the details. Of course, we can't get into the details because that is not what we are here for. It's just for us to know that the generator is that component that gives energy, that empowers the X-ray tube. Okay. I'm told we have more than 10 minutes. So the generator has so many components. So many components. Inside the generator, we have the wave rectifier circuits. Inside the generator, we have the transformers. Inside the generators, we have the transistors. I mean the diodes, the triodes, the pentodes, the tetrodes, and so on and so forth. So the generator has a very, very huge function in supplying the right amount of energy to the X-ray tube. Because if you don't supply the right amount of energy to the X-ray tube, of course, we're not going to have an effective X-ray fluence or X-ray distribution. So the generator, I mean, ensures all of that. And one of the major components of the generator is the transformer. You said before. Just from the name, transform. It transforms something into something. The transformer is the generator, like every other transformer, transform the current, the alternating current from one level to the other. You have a transformer which is a step up. That is, if you have a lower voltage, it can be stepped up to a higher voltage. In fact, in X-ray tubes, what we have there is the step up and transformer. So we have two types of transformers: step up transformer. You have the step up and then step down. So on a street, what we normally see on a street are step down transformers. We have the gigantic piece of an electrical equipment that we see so many wires coming, drawing wires and so on. Those are step down transformers. They step down the voltage which we get from the distribution companies, the energy from whatever. As you might be using 11 kV, 11 kV, kilowatts, 11 kilowatts or 33 kilowatts. They come with so many coinage, so many names. Instead, this one is federal, this one is blah blah blah. So it depends on the. So this step down transformer steps down this energy to this kilovolts. Sorry, kilovolts. It steps it down from this 11,000 kilo. 11 kilovolts. It is an 11,000 volts. So what we use in our homes, which is around 240 volts. So, but for our transformer, which we use in the cathode, in the X-ray tube, we have to have a step up and transformer, because for you to drive the electrons from the cathode to the anode, it requires around 150 to around 400 no, around 40 kV. In fact, from 20 kV to around 450 kV. That is why this is the maximum you see in almost all X-ray tube, 150 kV. So you need an energy, you need a step-up transformer to step up the voltage of mostly 400 for single phase, which we use in our domestic. It's around 220, 200, so on and so forth. For other countries that use some countries use 100 and then 110, 100, like I think the US or so. Yeah, US uses that 100. So they also have to step up their transformer to be able to go up to this 20 kV. And this 20 kV, 20,000. Volts. We need 20,000 volts. So up to 150,000 volts. That is the energy required. That is that we use in driving these electrons from the cathode to the anode. So for us to do that, we need a step-up transformer, which is able to step up this voltage of at most 400 volts to 20,000 and even up to 150,000 volts. So step-up transformer does that. And it does that based on the principle of electromagnetic induction. Not that with the principle of, the principle of transformer. The principle of a transformer. We don't need to go into that. Right from our secondary school physics, we know the transformer. We have the primary side and the secondary side, all those stuff. Depending on the number of turns in the primary side is the primary current is coming from here. This one will be a primary, this here secondary. If you have the number of turns here greater than the number of turns here, then we have the step up transformer. But we have the number of turns here greater than the number of turns on the secondary side, we have a step down transformer. And this piece of equipment that we might have in our homes, it is called a step up and step down. It can step up electricity voltage from, especially when you have some piece of material equipment, electronics coming from the United States, you usually need to step it up to the one we use in our local in our country here, which is 240 volts. So you need a step up and transformer to do that. So you just unplug, you see the plug there, you should know how to do it. But if you don't, of course, one needs somebody who's experienced on that to do the actual plug orientation. At times, people can even dangerously use that step up transformer. When the current goes so low, voltage, when the voltage in their community, on their, in their area goes very low, they'll just use the step down, that transformer as a step up and transformer. It is very, very dangerous because when the normal voltage now comes up, maybe 220, you just hear something will just go close to 400, 440, and that can cause some disaster in the home. So we have, so these are the major, these are the major parts of the the generator. Another part of the X-ray tube we need to also talk about is the AEC. AEC, automatic exposure control. Automatic exposure control. When we are exposing, when we want to do an exposure, 1 minute, 1.5 more minutes. When we want to do an exposure, you have you put a detector on the patient this way. The AEC is normally attached. It has this one normally has a detector somewhere. It calculates the amount of radiation needed for a particular optical density. When it has reached that preset optical density, which is required for the right darkening of the film inside the screen film, if something does shuts. So it is a cycle. The cycle that does that is the AEC cycle. So it is also part of the component of the overall X-ray, whatever, X-ray assembly that we have. AEC, very, very important. It's a timer when you activate it, except you don't want to use the AEC. If you don't want to use the AEC, then you have to manually select the stops. For example, when we are doing some of our QA, we don't use an AEC. We want to manually select our parameters. You want to set it 70 kbp, you want to set at a particular time, you want to set at a particular MAS. But during general radiography of a patient, the AEC is activated. Okay. Someone wants to ask a question. Maybe after this timeout. Ask your question after now.